So in example 5, again, each year the Long Beach Jackrabbits have an 80% chance of winning the World Pogo Sticking Championship. We want to find the expected number of championships that they will win in the next 5 years and the standard deviation in that total. So let's calculate that out. Again, I'm going to use my generic formulas for expected value and variance and standard deviation, and you can find those formulas on the 3rd slide in this lecture. So if you don't remember those formulas where they come from, just check back at the 3rd slide of this lecture and you will see the following formulas. The expected value of y is n times p. This is for the binomial distribution. The variance of y is npq. And the standard deviation, which is always just the square root of the variance, so that makes it, in this case, the square root of npq. So we're going to calculate each one of those for this particular problem. N, remember, is the number of trials that we're running. And in the previous example, we were running this over 7 years, but now we're just running it over 5 years. I'm getting that from right here. That's my n. N equals 5. Probability here is, the p here is the probability of winning any particular year. And we were given that that's 80%. So as a fraction, that's 4/5. And I'm going to go ahead and figure out what q is. Remember, q is always 1 minus p. So that's easy. That's 1 minus 4/5 is 1/5. And I think that's all I need to know for this one. So let's go ahead and calculate these out. The expected value, the expected number of championships that we will win over the next 5 years is n times p. So our n is 5, p is 4/5. So that's just 4 championships. And that, of course, should not be at all surprising because, well, we're going to play for 5 years in a row, and we have an 80% chance of winning in any given year. So 4/5, we expect to win 4/5 of the years. So if we play for 5 years, we expect to win 4 out of 5 of those years on average. So that's a very intuitive result there, but it's good to have it backed up by the formulas because probability can sometimes be counterintuitive. Let's go ahead and find the variance. We're not being asked the variance in the problem, but it's kind of a stepping stone to finding the standard deviation. So it's worth finding the variance. npq is 5 times 4/5 times 1/5. Now the 5 and the 1/5 will cancel, so that's just 4/5. So that's the variance. That's not our full answer yet. To get our full answer, we want to find the standard deviation, which is the square root of the quantity that we found above, the square root of npq, which is the square root of 4/5. And I could distribute that square root into the numerator, get 2 over the square root of 5. Not a very enlightening number, so I did go ahead and plug that into my calculator. And what my calculator told me was that that is 0.894. So that's the standard deviation in the number of championships we expect to win over a 5-year span. Go ahead and box that up because that's our final answer there. So just to remind you where everything came from here, I got these formulas for expected value, variance, and standard deviation straight off the, I think it was the 3rd slide of this lecture series. So you can just go back and look up those formulas. Those do correspond to the binomial distribution. Make sure you're working with a binomial distribution before you invoke those formulas. This one is a binomial distribution because what's happening is that the Long Beach Jackrabbits are playing the championship year after year, and each year they either win or they lose. You can think of that as being almost like flipping a coin, except that it's not a 50-50 coin because the Jackrabbits are so dominant that every year the coin has an 80% chance of coming up heads. Every year they have an 80% chance of winning and only a 20% chance of losing. So the expected value for a binomial distribution we said was NP, variance NPQ. the standard deviation is always the square root of the variance, square root of NPQ. Now we just drop in the numbers, and we get the numbers from the stem of the problem. So our N is the number of trials that you're going to run. In this case, that's the number of it's the number of possible championships. And so we're going to play for 5 years. So that N equals 5 comes from right there, from the stem of the problem. P equals 4/5. That comes from their chance of winning in any given year. So 80% translated into a fraction is 4/5. And then the Q is always 1 minus P, so that's 1 minus 4/5, 1/5. And now we just plop those numbers right into our formulas. The expected value is NP, simplifies down to 4 championships, which makes perfect intuitive sense. If you're going to play for 5 years and you've got an 80% chance of winning each year, you expect to win about 4 championships on average. Now, the variance NPQ simplifies down to 4/5, but that's not what we want. We want the standard deviation, which is the square root of the variance, and so that's 2 divided by root 5, and I just threw that number into my calculator, and it spat out the number 0.894 is the standard deviation in the number of championships that we expect to win over any given 5-year span. So that wraps up this lecture on the binomial distribution. This is part of the probability lecture series here on Educator.com. Next up we'll have the geometric distribution, so I hope you'll stick around and learn about that. It looks a bit like the binomial distribution, but there are certain key issues where it's different. In particular, you're not running a fixed number of trials anymore. You're running the trials over and over until you get a success. So that turns out to change the probability distribution, and it's going to change our mean and variance and so on. So we'll work all that out in the next lecture. I hope you'll stick around for that. In the meantime, as I said, these are the probability lectures here on Educator.com, and my name is Will Murray. Thanks very much for watching. Bye-bye.